Right, what am I doing? I'm all over the place, I know. I know I haven't finished that triskelion sphere, which I will come back to, but my hand is just about healed up now, so I can just put pressure down with this thumb. So it's a little bit more and I'll be returning to that. I got distracted by that thing, so twisted torus, that's complete, so I've just got to make a little stand for it, which is a 5-minute thing. And then I got distracted by this. After making this star, 30 pointed star, I thought, in this there are 12 conical stellations and 20 of these triangular stellations, and I thought, can I, and the two in the dodecahedron there are 12 faces which are equivalent to these conical stellations, and two of them of course are taken up by the finial, the stems of the finial. And I thought, can I do it so that I can get all 12 points of the star on it? And this led me into this whole thing down, noticing that if I take 4 equilateral triangles, and I'm doing this by proof by construction, in a sphere, that is another way of marking out the dodecahedron, and that takes 2 points, 2 of the 20 points of the star, the icosahedron, as the axis. So instead of the axis being this way, it'll be that way, and that gives you 12 conical points and 18 triangular points. So I'm building that model, but I don't need it. I think that's enough to prove it. I marked out a dodecahedron on a sphere, put it inside this spherical perspex bauble, marked on the points of the dodecahedron, and then just position those in, and it works out. I will turn that into a model, and I might make it in brass. There's the one that I turned, and you can see point of the icosahedron with the triangle equilateral of the dodecahedron points around it. Then facing in the opposite direction is another triangle. Then below the equator, calling this the North Pole, is another triangle facing, of the same size as the middle one, facing in the opposite direction. And then towards the South Pole is another triangle the same as this, but facing in the opposite direction. So 4 equilateral triangles describes an icosahedron really, but I've always referred to these points as the dodecahedron points, so I'll stick with that. Apart from that, I got onto turning these little 24mm versions of this. You can see that's a bit challenging. I've still got to make the chuck for that. And the other thing that I will be doing is making something like that, but with the star inside it, 40mm size. So that's going to be challenging, because the skew needed to do that is just a 2.5mm skew. So, and I've got to make the chuck for that as well. Okay, that's enough for now. I think that I made a post on Facebook and it was probably a bit confusing. So this hopefully is a bit clearer, an explanation of how, what that's going to give us, sorry, is a finial with 3 conical points instead of like this has got 5 going round and then another 5 going round facing the opposite direction, this will have 3, then 3, then 3, then 3 conical points. So it'll look very different is the point. And yeah, that'll be an interesting one to do. So I've got like 4 or 5 projects on the go, as well as making the chucks, but I'll get full circle eventually. Thanks for watching.